Can you see the difference between the two scenarios? The pair of hands on the right side of the screen is much cleaner. But why was there a difference? The answer is soap. We all know soap, and it is something we use in our daily lives. So what is soap? The soap we use in our households is actually a combination of many ingredients. But the main component that allows for its effectiveness in removing dirt is actually a molecule called sodium stearate. This molecule is used in soap because of its amphiphysicity, also known as possessing both hydrophobic and hydrophilic properties. Hydrocarbon tail is non-polar or hydrophobic and can readily dissolve in oils and fats. The carboxylate head is polar or hydrophilic and can dissolve in water. Water and oil do not interact, and would actually prefer to stay as far away from each other as possible. And yet when sodium stearate comes into the mixture, the two otherwise opposite in molecules begin to interact. It's similar to finding out that your arch-nemesis is of the same party you were invited to. But then, the host of the party, your mutual friend, comes along and pulls both you and your enemy together. Now you're forced to interact with your enemy, whom you would never otherwise even say hi. So how are the soap and the host similar? First, we must explain the obstacles that come from water's inherent characteristics. Water is a polar molecule. There is a slight negative charge on the oxygen, and a slight positive charge on the two hydrogen. Polarity of water causes water molecules to be attracted to each other. This attraction of molecules of the same kind is called cohesion. Hydrogen bonds hold the water molecules together. Collectively, the cohesion of many water molecules forms surface tension. The water molecules are more attracted to each other than other molecules with different chemical properties such as oil. And so the net effect is an inward force that packs the molecules into a spherical-like shape in a drop of water. Surface tension prevents water from spreading across an oily surface of dirt. Sodium stearate is a surfactant due to its amphiphysicity and the ability to reduce the surface tension of water. Its hydrophilic head can form bond with water molecules, disrupting the hydrogen bonds between the water molecules, therefore weakening the surface tension. Sodium stearate is introduced into water-containing dirt. Its hydrophobic tail will avoid contact with the water by burying itself into the dirt particle, leaving the hydrophilic head sticking out into the water. Multiple soap molecules come together, forming a micellar with the hydrophilic heads outward and the hydrophobic tails inward, trapping the dirt inside itself. The dirt then can be washed away along with water. And that is how soap works to remove dirt. So, how is soap synthesized for mass production? Generally, the source comes from cow. Tristearin, the triglyceride of stearic acid, is obtained from cow fat. It is treated with sodium hydroxide under high heat to get sodium stearate, as shown in this reaction. Sodium stearate is a white powder. Cosmetic companies must formulate soap in such a way that is appealing to the consumer, such as adding fragrance and moisturizing properties. The invention of soap skyrocketed to popularity and has since become an integral part of modern society.